Alright, hey guys, Mr. Kyle Myers Mathematics, and this one is going to be a little bit shorter of a video because I actually got stuck on this one. Normally I make these in real time, meaning like it's the first time I'm looking at the question, but I started to work this one out and I actually erased a couple things, so this isn't all of the different work that I did, but I wanted to try to leave up as much as I could think to leave up once I was thinking about it, and I was like, oh no, I should leave this up because I think this would be helpful to see for somebody, maybe. But there's like one or two other strategies I tried, and I just could not find anything to work for this. This one was a tough one. So my very first thought was actually the B sub n here, the B sub n series. I was thinking, because it's being times by 2, but then the pattern of the pattern is that it's being times by 2, then maybe it would be like 1/2 to the 2 to the n, because it's dividing by a 2 kind of, so that's like a geometric thing, so like a 1/2 geometric series, but then it's to the 2n, so that's kind of where my mind went first. But that did not work. As you can see, it actually increases a little too fast. The pattern of the pattern is not 2. The pattern of, actually, if you kept going, it just keeps going and going, because if you look here, it's like 2, 4, 16, 256, 2, 4, 16, 2, 4. So it's like infinitely increasing. So it's like it's literally an exponential. So that's not going to work. So then I think there was a couple others that I tried when I first made the video, and I don't remember what the other ones were exactly. They were just variations of that, essentially. But just today, making this video, or at the time that you're watching it, it would have been today. I stumbled across a couple other ideas. So I was thinking, oh well, c to the n, 1 over, if you can see that there, 1 over 2 to the n. And then that's actually when I thought, I was like, oh, okay, this is another dud. But if you look at the pattern to the pattern of the c to the n, it has a consistent pattern at least. So, okay, like we're getting somewhere here. The pattern to the pattern is consistent. So as long as we can get it to work, but then it's like, well, I can't decrease it. It's already 1 over 2. What do? Make it 1 over the square root of 2? I can't do that, because if I make it 1 over the square root of 2, then like all the odd powers of n are going to be root numbers, and I don't have any root numbers, so that can't work. So I tried something else. I was like, okay, well, what happens if I increase it instead? And so I did a d to the n. I knew it wouldn't work, but I was like, okay, let's just see if it does increase in the way I think it would increase. And it did. It's 1/16 is the pattern to the pattern. And I was like, okay, so it got doubled. So I do need to try to figure out how to make the square root of 2 thing work. I was like, well, but I need that square root of 2 to go away, because it needs to be taken to an even power. But if I take the square root of 2 to the 2n power, so that it's always to an even power, that's not going to work either, because then I'm just back where I started, because it would be the same thing as just 1 over 2 to the n. So I was like, okay, well, what else can I do? And earlier I was thinking that when you look at the pattern here, it's 8 is the 3rd power of 2. So it's like an n-1 almost. And I was like, okay, so that's 2 to the 3rd is how you get to the 4th one. In order to get to the 4th n, you do 2 to the 3rd here. And then in order to get to the 3rd n, right, in order to get to the 3rd n from the 2nd, I have to do 2 to the 2nd power. So there's definitely an n-1 thing going on there. So I was like, let me just try it, like n-1. But I also need the n, and I was like, oh, okay, well, this kind of works, because if I have an n and an n-1, then I'll always have an even number, because one of them will be odd and one of them will be even. And that way I'm always taking it to an even power without having to take it to the 2n power. And I tried that, and that, lo and behold, finally worked. So I don't know if there's a faster way to do this. This one was pretty tough. I scratched my head on this one for a little bit. I think it took me, I don't know, like 30 minutes, something like that. So this one was tough. Not the toughest math problem I've ever done by a long stretch, but it was up there. I mean, I don't know, top 100, I guess, maybe something like that. But yeah, this one was tough. So hopefully that's helpful. If at first you don't succeed, skydiving's not for you. But at first you don't succeed, try again, right? So hopefully that's helpful, and we'll be moving on. on to another set of problems after this. And sorry I got behind. I did get kind of stuck, and I was like, you know what? I'm just gonna like let this one cook in my subconscious for a little bit. And also, it was Easter weekend, so I'm gonna use that as my excuse. So yeah, but we're gonna get back on track. And I'll catch you guys in the next one. Don't forget, you can get my free PDF guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's on my website, Myers Mathematics. Link in the description below. And I'll see you guys next time.